Welcome to the Google Cloud Platform Education Series. My name is Jeff Davis, and in this session we'll discuss creating best-in-class storage solutions with Google Cloud Storage. We'll be doing a moderated Q&A throughout the session, so feel free to present your questions in the Ask Your Question Here field. Let's get started. So this is our agenda for the session. We're going to begin with a series of demos. These are going to highlight the most typical use cases and just how easy it is to set up high-performing, really functional solutions on top of Google Cloud Storage. Out of the demos, we'll move into a discussion of the overall GCS feature set and how it might apply to challenges that you're tackling within your organization. We'll take a few minutes to talk about the best ways to find information after this session, if you have questions. And we'll also talk about how to evaluate GCS for specific use cases, specific problems that you're trying to solve. And again, throughout the session, feel free to submit your questions. So, on to the demos. The first use case that is very typical with GCS is using it as a target for offsite backups. So I'm going to bring up a piece of backup software. This is a product called Retrospect. There are lots of different products in this class. Veritas, for instance, is a partner with Google and has their net backup solution. Lots of solutions will actually take your on-site backup data and pump it into the cloud, where you have then an offsite backup and it can be stored large amounts of data for very small amounts of dollars. So what we're going to do is we're going to start by configuring the product so that it will use Google Cloud Storage as its target location. So I'm going to create a media set, and you'll notice that I have a variety of options. I'm going to choose to send it to the cloud. We're going to call this demo backup set, and we'll go ahead and encrypt it and give it a simple password. Now, at this point, I'm prompted for what backend cloud service I want to use. And I need to use a configuration string provided to me by Google. So that is Storage APIs GCP Webinar Backups. And then I need an access key and a secret key. And this is easily configured within the Google Cloud Storage user interface. So I'm going to actually go to Google Cloud Storage. This is my project. I've got a set of buckets. You'll notice my GCP Webinar Backups bucket is here. I'm going to click on Settings, Interoperability, and you'll notice that I already have some keys created, so I'm going to actually use one of these keys. So I need the access key, and that's going to go here. And then I need the secret key, and that's going to go here. It uses SSL to transfer the data, so it's encrypted in flight. And now I have my backup set. Now I'm going to actually do a backup. Retrospect can back up an individual machine, which is what I'm going to do here. It can back up all the workstations on a network, or it can back up multiple servers on a network. So this could be backups of your internal servers that are application servers or file servers, as well as backups of all of your important workstation data. So I'm using this simply because it's easy to install and it's relatively quick to demonstrate. So I'm going to select what I want to back up, and I don't want to back up my entire hard drive because we'll be here too long. Instead, what I want to do is I want to pick a videos folder. I'm going to back that folder up, and I'm going to back it up to the cloud. Notice it's a cloud demo backup set, and I'm going to run it. Now, it takes a little while for this backup job to execute, so I'm going to go ahead and let that run in the background while we move on to the next part of the demo. Let's take a look at performance. One of the things that you care about not only is storing large amounts of data inexpensively, but you want to make sure that your access to that data is fast and is also reliable. So again, if I go to my bucket browser for this project, you'll notice that I've got a variety of buckets other than my backups bucket. So I have a regional bucket in the west of the United States. I have a multi-regional bucket, and then I have a nearline bucket and a cold line bucket. And these are 4 different storage classes. And I'm going to show you how performance looks for each one of these, and then we'll talk about the differences in a little bit. So in order to test performance across a variety of areas, I've actually created a bunch of test instances. So you'll notice that I've got virtual machines running in different parts of the world. So I've got one in Asia, I've got one on the East Coast, which is not in the same region as my regional bucket. I've got one on the West Coast, which is in the same region as my regional bucket, and I've got one in Europe. So what I'm going to do is I'm going to SSH into each of these virtual machines so that I can generate load against GCS. Okay, so let me shrink that window down. Notice my backup is still running in the background, so I'm going to shrink that down as well. And what I have here is 4 SSH windows, 1 to each of my different machines. So I'm going to use a curl command. Curl is a command that basically is going to do a URL request. The items that I'm pulling out of the buckets have actually been made publicly accessible and can be accessed using a standard URL. So what I'm going to do is I'm going to copy down a relatively big file from a regional bucket. So this bucket is stored in the West Coast. And what we really want to see is it fast, man? Can I pull down big files really quickly? So I'm going to go ahead and enter this command in each of the windows. And what this should do is start a file download from 4 different instances in 4 different regions. And what we want to see is what does the performance look like. Okay, so if I look at the instance in the West, you can see I'm averaging 292 megabytes per second download. That's pretty quick. If I look in the East of the United States, it's about 314 megabytes, so roughly the same performance. If I look in EMEA, it's 203 megabytes. And this is because the client that's running in Europe is accessing resources stored in a Western region bucket. That means that it is not connected with the same high throughput, low latency connections that say this instance in the West Coast is. So relatively quick, we averaged, it looks like 96 megabytes per second. In Europe, we averaged 85 megabytes per second. In the East Coast, we managed about 100 megabytes per second. And in Asia, about 92. So pretty good performance around the globe from data that's stored in the western part of the United States. I'm going to do the same thing, except I'm going to copy this not from my western regional bucket, but instead from a multi-regional bucket. So a multi-regional bucket is a bucket where your data is actually replicated not just in the western United States, but in the central and in the eastern United States as well. What this means is that it's going to be closer to a wider range of clients. So again, I'm going to copy this and we're going to start it in Asia, and then we're going to go to Europe, and then we're going to go to the western United States, and there was one more in there. There's the East. And you can see that the multi-regional bucket is even faster. Right, so again, we're at roughly a gigabyte per second in the West. In EMEA, we're at about 500 megabytes. In the East, we're at about a gigabyte. And in Asia Pacific, we're at about 413. So again, multi-regional buckets even faster than the regional buckets. Now, I'm going to do a small file from the multi-regional buckets. And this is important for the next test, which is the nearline test. So what I want to do is I want to see if you download this small file, how fast is it? And again, super fast, super fast, super fast, super fast, okay? Now, nearline, as you may know, nearline is a less expensive storage class that's intended for data that isn't accessed that frequently. So they move it a little bit further away from the standard access points, means that you can access it, but it is going to cost you every time you read it. We'll talk about the pricing in just a second, but what I want to show you here is even though you've moved it to a tiered storage offering, it doesn't actually slow down the speed with which you can access or download the files. So here we go. You'll notice from nearline, I'm still seeing 652 megabytes. I'm seeing 440 megabytes. I'm seeing 761 megabytes. I'm seeing 380 megabytes. Notice you had like access time was tens or hundreds of milliseconds. It was really quick. And it was the same command to access it from nearline as from a regional or multi-regional bucket. And let's go a step further. Let's go to cold line. So cold line is even less expensive. It's intended for data that you only access very infrequently. But again, use the same access mechanisms and you get the same retrieval speeds as you do from standard buckets. So you'll notice 413, 778, 511, 929. So even though you've moved to tiered storage and you've gone from regional to nearline to cold line storage, you haven't had to sacrifice initial access time or download throughput or change the APIs that you use. This is a big plus relative to some other solutions that are available to you. In the meantime, let me go back and check the backup software. You can see that the backup is actually running. We'll take a look when it's done to see that it's actually stored the stuff in the bucket. So we've got backup running. We've just showed performance and the relative performance of a multi-regional bucket versus a regional bucket versus nearline versus cold line. So now let's take a look at a couple other things that you can do. So one frequent use of Google Cloud Storage is to store large media objects for serving on websites. So here we have an example learning management system that's got videos embedded in their micro-learning lessons. And you can see this module is all about the fact that mantas are awesome. This is a video that I took while diving with mantas off of Kona. If I load this page, you can see that it actually is streaming the video to my machine. Now, this video is stored in Google Cloud Storage. And in fact, if we go to the Cloud Storage UI, what you can see is here's a bucket for that project. And this bucket has got a couple of copies of the Mantas streaming video file. It has a bunch of other ones as well. So what happens is you set up your web server and it simply proxies these media files. You can see that these files are shared publicly and there's a public link option. If you click on the public link, this actually gives you a URL and you can serve the video directly from GCS. Oh, there's me talking about something else. Okay, so this is a very common application and it's super, super easy. You just upload your files, you click on share publicly, and you get a link that you can then publish within your web pages. So let me close those two windows. I'm going to check on my backup and see how we're doing. It's still thinking about it. Okay, so I'm going to let that continue to bake in the background. It's going to go into the webinar backups bucket. And you can see that there's a demo backup set, and this is where the backup is occurring. It's not done yet, but it's backing stuff up. Okay. Let's look at another application. So GCS is a really good place to stage data that you are moving into or out of data analytics jobs. So here's an example of a big analytics table that I use for a customer success application that I've built. So you can see that this is a BigQuery table. It's not that big, right? It has 525,000 rows. There are obviously much bigger ones. If you look at the BigQuery samples, you can go to the Wikipedia benchmark and you'll see that they've got 1 million rows, 1 billion rows, 100 billion rows. So that makes my little data set look paltry, actually. But 525,000 rows would be a lot to write row by row. So instead, what we want to do is we actually want to import this data. And the easiest way to import it is you upload it to GCS, and then GCS has a really easy integration with BigQuery. So if you look, here's a bucket. This is the bucket associated with the Success HQ software. That's the customer success platform. And you can see that we have, it's not a huge file, but it's a 48 megabyte file. And this has got the 525,000 rows. So this could be, think of it as being 500 million rows. Again, you just upload it to the bucket. And then in BigQuery, if you want to import it, you simply say, I want to create a new table. And you say, I want to choose a file. Actually, I don't want a file upload. I want to do Google Cloud Storage. Okay. And then you need the path to the file. So that's going to be in the, let's see, yes, gs://shq transfer / and then the name of the file is this. And then I could specify the schema explicitly. I'm going to actually have BigQuery try to automatically detect it. And I'm going to give it a demo events table name and create a table. And this then inserts a job, and it's going to import the CSV file from Google Cloud Storage. It'll take, if I'm not lying, about 5 more seconds, and it should be done. You'll notice here we've got the entry showing that the demo events table is loading. Oh, there we go. We're done. So you'll notice it's created fields for each one. In details, you can see that we've imported 522,000 some odd rows. And if I want to see that this data is in fact live, what I can do is I can, let's see, shrink this down a little bit, pick this, and I'm going to do select star from events.demo events table. So let's run the query. And if all goes well, we should see I get all of the event data that's recorded by my customer success system, and I have 522,000 rows. So again, that took about 10 to 15 seconds. If you extrapolate that, so if you go to 500 million, it's still a relatively quick import. And again, this is using GCS as a staging mechanism for getting data into BigQuery or into Dataflow or into Dataproc. It's also a great target repository for GCP services. So any of those big data analytics tools can actually dump the data into Google Cloud Storage, and then you can actually share this with other folks. Let's switch back to my backup, and it looks like my backup is actually complete. So if I go to the backup bucket, I should now have a full demo backup set. And this was about 1 gigabyte of data. So you can see there's a 600 meg file and a 420 meg file. I had about 1 gigabyte worth of videos that I uploaded relatively quickly. So what we've got here is examples of a variety of different applications. We have files that are just stored for download. This might be appropriate, for instance, if you're a software company and you're distributing your application, and you want to make sure people can download the application and that it's highly available and a good download performance. We did backups where we took large amounts, in this case only 1 gigabyte, but again, if you did this across a bunch of machines, you would take all of that data and you would pump it up to the cloud, and then you could actually store these backups in various tiers of storage. So old backups you could have in cold line, and so forth. And we talked about serving media in web applications, and we talked about using GCS as a staging area for getting data in and out of big data analytics pipelines. Hopefully, you've seen at least 1 or 2 things here that really gets you excited and curious as to how you can leverage GCS for your company. So let's switch back to the presentation. And let's talk at a high level about the wide range of capabilities and the pricing information about cloud storage. So again, cloud storage is a unified storage product that runs atop of Google's massive storage and networking infrastructure. It is blob storage or binary large object storage. This is not a regular file system where you're reading and writing and updating data within files. This is where you store lots of files that are relatively static, and you read them periodically for analysis, or you just keep them in archival. And they feed into things like live data serving or analytics, that sort of stuff. You have one consistent API to access all of the different types of storage. You have similar latency and download speeds across those classes, which makes it super easy to work with. So here's a slide that we're going to spend a little time on. This details the 4 different storage classes and their differences within Google Cloud Storage. So the one that most people start with is regional storage. And remember, in Google Cloud Platform, a region is a collection of resources that are interconnected with high throughput, low latency network connections. That means that an instance in the West region can read and write data to a GCS bucket in the West region very, very quickly. Your data, when you write it into Google Cloud Storage, is actually replicated across machines throughout the region. What this means is you have very, very high durability and very high availability. The likelihood that you are going to lose data is extremely low, because even if a particular storage device drops out, your data is replicated. Even if a zone goes out, your data is replicated across other zones within the region. Your data is also highly available, which means that, again, if a zone goes down, you'll have live copies of your data in another zone within the same region, and you can access it there. Then people sort of move to multi-regional. Multi-regional is where you have resources that are holding your data, and they're not just spread out within a region, they're actually spread out through what's called a multi-regional area. So there are 3 multi-regional areas in Google Cloud Platform. There's a North American or a US region, there's an EMEA region, and an Asia Pacific region. So this gives you even higher levels of availability. If the Western region goes down, you can still read your data from the Central or the Eastern region. So you can see actually that the availability is better with multi-regional as opposed to regional. You also get a performance improvement in that because your data is in multiple locations throughout the United States, it's more likely that any given user will be closer to that data. On the right-hand side, then, you have nearline and cold line storage. And these are intended to hold data at reduced costs, but it's data that you don't access as often. So basically what happens is if you put something in nearline, Google essentially puts it someplace that it's less expensive for Google to store, but it's more expensive for Google to serve. So what they do is they cut the price for storage, but then they make you pay for accessing it. You don't pay a performance penalty. You still have access times in tens of milliseconds, and you still have high throughput, but they have to go through more contortions to serve the data at that speed. Therefore, while it costs less to store, it actually costs more to access. So it's really good if you access this data infrequently. So at the top here, we show this is intended for data that is frequently accessed across regions, within a region, accessed less than once a month, or accessed less than once a year. Durability is a lot of 9s. Availability, the worst case scenario is 1% of the time you might not be able to access your nearline or cold line data at a given point in time. And it's 3 9s for regional, and it's 3 9s and a 5 for multi-regional. You use the same APIs or the same GUI or the same command line utilities for getting data in and out of all of these storage classes. You have the same latency for reads. The difference here is on cost. So at the top end, the top shelf multi-regional storage class, you pay 2.6 cents per gigabyte per month. For regional, you get a discount. You pay 2 cents per gigabyte per month. Nearline, you pay half that. You pay 1 cent per gigabyte per month. What's interesting, though, is you pay roughly 1 cent per gigabyte to read the data off the disk. So if you read the data once a month, you about break even. If you read the data once every 3 months, you're clearly going to come out ahead versus regional. If you read the data 3 times a month, you would actually pay more for nearline than you did for regional. And then cold line, you pay 7/10 of a cent per gigabyte per month, but you pay a higher access charge. Now, storage, when it comes to the cost entailed in Google Cloud Storage, you pay this ongoing storage fee Then for nearline and cold line, you pay to access or read the data off the disk. And then you also pay for what's called network egress. So that is any data that leaves the region where the data is stored, you end up having to pay. And it starts at about the lowest price is about 8 cents per terabyte transferred. Now, again, if you're using a regional bucket and your server is in the West region and it's reading and writing to a cloud bucket that's in the West region, it never leaves the West region data centers, therefore you don't pay network egress. But for instance, with that learning management system with the little video lesson, I'm paying 2 cents per gigabyte per month to store it. And then every time somebody loads that page, the data is leaving the data center. And so I'm having to pay, between 8 and 11 cents per terabyte of storage transferred out of the data center. All in all, far less expensive than building the same type of infrastructure on-premise, also far more secure, far more reliable. Speaking of security, you can rely on not only Google's hardware infrastructure, but on their software and processes to secure your data. So Google has invested huge amounts of money developing processes, technical talent, and software that keeps its data secure. So they run at least a half dozen applications that have 1 billion active users. Those need to be secure, and they're basically leasing you space on their infrastructure. So for instance, all your data is encrypted. Google automatically encrypts the data. They hold the encryption keys and rotate those encryption keys on a well-documented basis. If you work in an industry where you have to manage the keys, you can use GCS with customer-supplied encryption keys. IAM is identity and access management. This is a mechanism that you use to control who can do what to which resources in your GCS projects. And the same permissioning scheme and authentication system that you use to manage access to compute engine instances or to BigQuery tables, you can use to control access to buckets and objects within your project. In addition to that, so for instance, editors on your project can read and write to all of your buckets by default. But let's say you have a particular bucket that you don't want every editor on your project to have access to. Only a very few particular people should have access. You have an additional layer of security, which is access control lists. And those access control lists can be set at the bucket level, and you can have default permissions set for every object inside, or you can manually and explicitly set access control lists on individual objects. In some cases, you want to make access to objects within a bucket available to people who don't have Google accounts. So one thing about IAM is it requires the person to whom you're granting roles to have a Google account. In a lot of cases, you are serving up media, and you may want to serve that to the public, in which case you set a special ACL that says it's available to everyone. But in other cases, you don't want it to be publicly available. You want to secure it for particular individuals, but you can't guarantee that those individuals have Google accounts. So there are code libraries available for developers to create what are called signed URLs. And these URLs basically have an indication of what a person can do to a given resource in GCS, how long that permission is granted, and then anybody who holds that URL can actually access without having a Google account. So this is not unlike those password reset verification emails where it goes to your email and it gives you a big long arbitrary link, and if you click on that, then you can reset your password, and having that link is your permission to reset your password, and it's only good for a certain period of time. This is similar in concept. And for those of you who develop mobile applications using the Firebase mobile development framework, Firebase actually has their own storage security rules system, which makes it really easy for developers to create security rules without having to worry about the particulars of GCS, and they apply directly to GCS on your behalf. Ways to get data in to Google Cloud Storage. So there are simple ways, there are interactive ways. So you can go through the GUI and click a button and upload a file. You can use the gsutil utility to copy a file from your local machine. But obviously, if you're doing large quantities of files or maybe really, 10, 100 terabyte files, doing sort of an interactive session from your local machine probably doesn't make a lot of sense. Other ways to get data in include integrations with other GCP services. So for instance, I showed you the BigQuery integration. You can just as easily dump a huge BigQuery table or the results of a big data process. You can dump that all out into Google Cloud Storage very easily. There are third-party integrations, and the retrospect software that I showed you was an example of that. That is third-party backup software that writes data directly into the cloud. For really large volumes of data, you might go with a third-party service or a third-party appliance. So companies like Zadera basically create appliances that they put on-prem, and they act as bridges where they pull huge amounts of on-prem data and they pump them through very high-speed network connections up into the cloud. And then third-party services would be something like Iron Mountain, who will actually come to you, pick up a bunch of your media, take it off-site, and upload it to the cloud for you. Getting data out, sort of the reverse process. So again, you can do it interactively, so you can just click on a link and download a file. You can use GSUtil to copy files out of the cloud onto an on-prem device. Again, data can go out of GCS into other Google Cloud Platform services very easily. We showed that with BigQuery. The LMS system that I showed you, where you had that little video module about mantas, that's using proxied web access. So basically you hit a web server, and the web server, when it sees a URL pointing to a Google Cloud Storage URL, it will proxy, it'll grab the data out of GCS and then serve it up. Or you can even serve files directly out of GCS. So I showed you where the public links are. If you click on that link, GCS actually acts as a web server. So you can upload a bunch of static files and run a web server out of GCS without any additional software. To manage your data, I've already highlighted this a couple of times. You have a consistent set of APIs that you can use across all the storage classes. There are also some really cool features that make it easier to keep just the right amount of data and just the right versions of data. So for instance, there's lifecycle management. What this allows you to do is say, hey, any files that are older than 365 days, I want to move them into nearline from regional. So I actually want to move them into a different storage class, and therefore I get to save money. Or I want to only keep the latest 3 versions of a particular file and throw away anything older than that. So you set these as little JSON snippets. They describe what a particular bucket or object does in terms of lifecycle management, and then the system takes care of it for you. Speaking of versioning, there is object versioning within GCS, and what this allows you to do is basically say when you overwrite an existing object with a new object, it keeps the previous version. And so you can overwrite it over and over and over again and have lots of different versions of the same object. And then at any time, you can list those versions and you can actually recover a version that has been previously stored. Now, obviously, you have to pay for all these multiple versions, so that stacks up. And that's why you combine it with lifecycle management to maybe age out and only keep the last 3 versions. An object change notification is a feature whereby you can have a bucket notify an external application every time a new object gets dropped into the bucket, for instance. So let's say you had an application where users uploaded photos, and every time a photo got uploaded, you wanted to actually create a thumbnail. So you wanted a service to open the image, shrink it down, and save the thumbnail in a database, for instance. What you would do is you would configure object change notification on the bucket. Every time a new file gets uploaded, a webhook fires, talks to your server application that then responds by creating the thumbnail. Okay? So given all these capabilities, you want to start thinking about where could we leverage cloud storage to solve problems for our business. One example here is the Autism Speaks project. So what Autism Speaks wanted to do was create a really large shared data set about genomic information related to autism. So every sequenced genome takes up to 200 gigabytes of data. They started by sequencing roughly 1,300 genomes. So this created over 100 terabytes of data. Now, 100 terabytes of data doesn't seem that large. But remember, the target wasn't just these 1,300. They wanted to have 10,000 plus people who had their genomes sequenced. And now you're talking multiple petabytes of data. That's a significant amount of data. Where can you store this data so that you can control who has access to it, you can host it relatively inexpensively, and it has high performance downloads around the world? Well, they did it on Google Cloud Platform using GCS. So they ended up creating this data set that could be used by the best scientists in the world to run analyses against trillions of data points to try to find new ways of addressing autism in individuals. You may not have something quite this big, or you may have something actually bigger. In any case, GCS probably will work really well for you. Now, after this session, if you come up with questions and you want to learn more about cloud storage, where do you look? Search is your friend. If you search on Google Cloud Storage and then whatever topic you're interested in, it's very likely that the first link is going to be what you want. So for example, here we've searched on Google Cloud Storage classes, and what we get is a link to the article that has all the information that fed the table that we looked at earlier. If you're trying to figure out the right command line structure for doing things using the GSUtil utility, type in GSUtil and then the action that you want to perform. So like GSUtil copy or GSUtil move or GSUtil rename. Again, like every other GCP project, the Google Cloud Storage documentation at the top level has got this nice 6 sections. It's got a quick start. It's got a series of how-to guides, such as how to create buckets, how to upload or download files, how to create signed URLs. That has deep dives into the APIs and general concepts. It has tutorials and other resources, including pricing information and link to a pricing calculator, which you can use to sort of predict what your costs will be. Some things to consider as you're evaluating applying Google Cloud Storage to particular use cases in your organization. Again, have a process and be methodical. It's not hard, but do a good job of it. Figure out what it is that you need to know in order to determine if GCS is appropriate for the use cases you're thinking about. Figure out what you need to test and what your sort of acceptance threshold is. So for instance, we need to know that we get X kind of performance in Australia, or we need to know that we can keep our monthly budget below a certain level. Then figure out how you're going to do the testing. So you need to figure out how many buckets, how many objects, how much data, what kind of integrations you're going to use with third-party products and so forth. And do a little bit of research to figure out how you're going to implement it, and then figure out who's going to participate. Somebody probably is going to architect the solution, somebody is going to be responsible for setting it up and operating it, and then somebody's project managing the whole process, collecting the results, analyzing the results, and then obviously your business leaders will be making a decision. Again, timelines, you can typically do one use case within a month. Often it can be faster than that, although it depends on how complex the solution is. Typically, you break this down into one segment that's about defining your criteria, recruiting your team, and agreeing on what you're testing. A second segment, which is figuring out how you're going to test. This is generally some point testing and some trial and error and some research. And then ultimately, you perform your tests, you collect your data, and you analyze the results, and you make a decision. If you put more people against this, you can get more use cases tested out in the same timeline. If it's a really sophisticated solution, it may take you a little bit longer. But hopefully, this gives you a sense of how to tackle the evaluation of GCS as an appropriate technology for your use cases. And that's it for this session. Thanks so much for joining us. I hope you learned something and that you enjoyed it. We'll be sending you a follow-up email that has a link to a code lab where you can get your hands dirty and try GCS out for yourself. We'd love your feedback, so make sure to provide that on screen, and stay tuned for our next session.